I don't know.
Venus, Mars, Jupiter,
We just changed it to an astronomy class at this point.
Uranus,
All right, good afternoon.
Saturn, and I'm missing one more planet.
We're continuing 3.1 today. We almost finished the second one, and we were halfway through the third one as well. Again, in this section we first define quadratic functions or square functions. We call them quadratic all because we have this term. So this term must exist certainly. The other two are optional. They may disappear sometimes. But in standard form, you expect to see all three present. And I call this equation actually useless form, standard useless form, because we don't get much information from this equation. You only get some basic information about the shape of the graph, and that's pretty much it. And to get the entire set of information about the quadratic function, we convert it into vertex form, useful form, seed form, whatever you call it. But what I know is x is complete under a square, only one spot, with a number added or subtracted to it. And there is a, still a is this old a in front, and there is a number popping up, a new number on the very end. This form is called vertex form, useful form, because all this information can be found using this form. We actually took a look at this one. I can get all 8 information here, actually it's 8, yeah, because this is already in vertex form. This was. We already finished this. Please somebody remind me, what was the vertex coordinates for this one? 2, 8. Yeah, you still remember it. We take opposite of this number and just whatever this sign is, we keep that sign for the second one. So it is positive 2, positive 8, the answer. Okay? We finished part A and then directly went into the next question and finished vertex form for that one as well. We left the fun part to do today's class. Fun part is getting all this information from the vertex form, but I will just do it again. Actually, close your notes, try to do it on your own. Let's see if you're gonna get the same answer as Friday. Alright, don't cheat. Get the vertex form. Let me know when you're done. Anyone done? I bet it starts with 3 x something something. All you need to do is find out 2 numbers, blank numbers. No answer yet? Anyone?
3 parentheses x minus 6 that squared minus 4.
Unfortunately, it's incorrect. How do I know? Because when I squared this, multiplied by 3, take off 4, it's not gonna be 23.
Minus 3.
Yes. I guess that's right. 9, 27, take away 4, I think you got it. 6 times 3, yep, this is the one. Alright, how do we do this? You first factor out 3 from the first two terms only. 3 factored out from first two. This is only x squared and this is 6x. And don't touch 23 for a while. I put some space here because there's gonna be a number coming up. And that number will be, you don't have to guess it, computer. That number will be 9. How? We take half of this number, square it. Half of 6 is 3. When I square it, it's 9. And then I have to compensate for this addition. I made this, so I have to compensate and take it away as 9 again, because I added 9, subtracting 9, right? Now, I subtract 3 times this number, which is 27. Agreed? And we're almost there. We now collapse this into a square. We're going to turn this into a square, and that square will be x and a number. That number is always half of this quantity, which is 3. Minus 3, same sign, but half. And finally, you compute this. It's minus 4. We get the right answer. Okay? Now let's pick up the fruits from this tree. You can identify the vertex. Now, all these parts is now 10-second questions if you know what you're doing. Identify the vertex. Somebody, please tell me the coordinates of this vertex. What is that, 3? Positive 3? And negative 4. Yes, it's positive because we take opposite of this number. Negative 3 is positive 4. Positive 3. But negative 4 is still negative 4. Part C, I need the x-intercept. To find x-intercept, you have 2 options. Isn't that amazing? You have 2 options. You can, but the same method, but 2 options to go with the equation to be used. Now we are finding x-intercept. We will set y into 0, right? Set y into 0 to get x-intercept. But which equation do you want to use? The original one, which is 0 equals 3x squared minus 18x plus 23, or the brand new one you got, useful seed form. Which one is more convenient? What do you think? Which one? Yeah.
Would you use the original one in case you made mistakes on the next one, or under a useful one?
I like that answer. He says, I may have made a mistake at this stage, so why don't we go with the original one rather than the part that may have a mistake? I agree on that. However, there is a small chance you may have a mistake here, but you can always catch it later. That mistake will always pop up somewhere as something won't align with the rest of the whole parts, so we will catch it if there's a mistake. Otherwise, if you go with this, how would you do that? How would you do this one? How would you find zeros of this quadratic function? How would you find out what x makes this 0? Is it easy? You have a couple options to do that. You can first, by trial and error, factor this as 3x something, 3x something. Can you guess those two numbers? What numbers you're gonna put here will multiply to 23, add to minus 18, and you FOIL it. You FOIL outside, inside that. Can somebody do it in 10 seconds? About 30 seconds. About 1 hour. Because you won't be able to get it. You won't be able to guess these numbers because they are not whole numbers. It's not like 23 and 1. It's not. You don't have another option. Either 23 or 1 or negative 23 and negative 1. Neither of them will make minus 18 when you FOIL it. So it's impossible to factor this by hand. Then, no, don't quit. You still have an option. What is the other method you can find solutions of this equation? There's a method called this is a quadratic equation solving. There's a formula called quadratic formula. Very good. Minus b plus minus square root b square minus 4ac over 2a. Okay? Now, look at this mess. Would you rather substitute ABCs here than doing this one? Look, you have to square b, take away 4 times a times c. You are more likely to make a mistake than here. And how can I check this has no mistake? There is a way you can check this has no mistake. How did I check and find Steven's mistake here? FOIL this, multiply by 3, and take away 4. If you are getting the original one, it doesn't have a mistake. So I'm pretty sure this doesn't have a mistake. Rather than doing this tough work, I will go with this one. Why is this easier? Because all you need to do here is add 4, divide by 3, take square root, add 3. 4 operations, simple operations though. Add 4, divide by 3 because 3 is multiplying, take square root, add 3. You will get the same answer you will get here, but less riskier. Here you definitely may need some calculators to double check your work. Here, all simple numbers. So I recommend going with the seed form or vertex form. So this is 4 equals 3 x minus 3 squared, and divide both sides by 3. And take square root of both sides. Square root of 4/3 equals square root of x minus 2 squared. These two will cancel. Don't forget plus minus though. There is a risk you can make a mistake here though. Don't forget plus minus. X minus 2 equals plus minus 4/3 and yeah, thank you. And we will add 3 to both sides, be done with this thing. Okay? 4 plus, you can take 4 out as 2 root 2 and 2 if you like. I'll leave it here. I'm not sure computer will like it though, but we'll test. So there are 2 answers here. These are gone. X equals 3 plus root 4 over 3, or x equals the negative option. Okay? Are we good? You will get the same answer and if you go with this but you will have a lot of problems taking square root out, canceling. You need to cancel stuff as well. This gets you to the answer quicker, safer. All right, part C is over. We got 2 intercepts. Now let's get part D, y-intercept. For y-intercept, it's easier than x. You set x into 0, but which equation would you rather use? This time it doesn't matter. You can go with either one. This is the only part I like the useless one than this one. Why? Just set x into 0. What do you get y? 23. Look how easy that is. Y is, just set 0 in axis. So y-intercept is 0, 23. Okay? Alright? Well, can I use this one instead? Yeah. You need to plug in 0 here, square 3, 9. 9 times 3 is 27. Take away 4, 23. Same answer. I don't know, I like kind of this one better for this purpose, but it's up to you. You can use either equation. Part E. Any questions? We're gonna sketch, I believe. Yes, we are gonna sketch this thing now. Do we have enough data to sketch it? Yeah, more than enough. You have y-intercept already, 0, 23. Well, it's up here. This is as far as I can go. This is 0, 23 y-intercept. Well, please somebody use a calculator and roughly tell me what these numbers are, because I need to see those. They're about 3 point something. This is 3 point something, this is 2 point something. What is it?
1.85 and 4.15.
Yeah, it's more than 1, so it's 1.85. Yeah. 1.85, and this is 3.1,
4.15.
yeah, 4.1. This is about 1.3. Square root of something more than 1 is more than 1 again, so it makes sense. So 4 and 2, about 4 and 2. Let's say 4 is here, 2 is here. Well, it's gonna be, how come this can, oh, okay, I see how. Because we're gonna locate the most important part. Where is the seed? Seed is gonna tell where the tip of the mountain is gonna be, or deep down point of the valley. Where is the seed? 3, negative 4. 3 is right between these guys, negative 4 is down somewhere here. Now this explains things. Now there is a seed here, 2 branches will grow from this green dot. There are 2 options. You can grow downward or upward direction. Now please, 3 points are above this green dot. Which direction can it be? Has to be upward direction, right? Besides, I knew it already from this number. What does this number say? The branches of the parabola opens upward direction. So I will go with this option. It's gonna go across this window. Okay? positive 3, negative 4. And you know where these are. This is 23. Should be up more high, but this is the best I can do. And F, axis of symmetry. What is it? It's x equals something. There is an axis going right between these two branches. I need to know its equation as x equal whatever this point is, and I have no clue. What do you think that point is? 3. It's the x coordinate of the seed. G, I think it's going to ask us maximum or minimum. What does this function have? Max or min? Minimum. And what is that value? It's the y coordinate. It is down 4 units down underground, right? So it's deep, 4 units deep. It's minus 4. H, domain and range. Domain of all quadratic functions is always the same. What is it? What is the domain of all quadratic functions? Yep, this is domain. All real line. Okay, how about the range? Range changes though. Range varies from function to function. And your best friend for range is pictures. This picture. Smash it to y-axis. Compress to y-axis. And look at the image it forms. It starts down here and goes up. Yep. All you need to do is type in all these into the connect math. Okay? Oh, yeah. Thank you. Have a bracket here because it's included. Always the maximum or minimum is included. Any questions? Any problems you may have with entering this data? Any part? Oh, I don't know how to enter this. We already did the same stuff in number 1, so you're going to repeat it. So just watch the previous class how I'm entering each part. And this is parentheses. Was it negative 3, negative 4? No, it wasn't. What was it?
That's the vertex form.
Oh, it's the vertex form. Okay. So this is 3 x minus 3. You're gonna square this and then minus 4. Now it's 3 and negative 4. Okay, etc., etc. Number 3 looks like pretty similar question, right? But I'm going to show you an alternative way. I want you to avoid using it as much as you can. I know this is really convenient what I'm going to tell you, but don't get used to it. This is like medicine. Don't abuse medicines, okay? This is like insurance for second way to check your work. You need to know how to make complete squares. I mean, you need to know this procedure I did because it's used widely in this class and later class, math classes. What is the second one? This is the formula option, cheating part, cheating option. This formula here quickly gives you vertex location. Seed location. That's all we are looking for, right? It gives you that quickly. By the way, we found this last time, right? What was the answer? No, don't tell me. I will get the same answer with the formula. How? all I need to do is apply that formula. Vertex location is minus b over 2a. Wait, I'm not gonna do this one. Wait for this second part. I will show you how to do this wait part. B, I need to go find B. Where is B? It's one of these numbers, it's 15. Now go find A, which is 3. We're done with the first half. 15 over 2 times 3, which is 6, minus 15 over 6, but please reduce this. 15 and 6 both divisible by 3, so it is 5 over 2. On Friday, what was the answer for this? Should be the same. 5 over 2. I remember it being 5 over 2. Okay? That's the vertex. Almost. We found the first half, but I said wait. How do I get to the second part? This one, wait part. Take this number you found and enter it to the function in x and compute y value that way. Because this vertex is on the curve. If I know the x value of it, by entering it into the equation, I can get the y value. All you need to do is compute this by entering negative 5 over 2 into here. So 3 times negative 5 over 2 plus 15 negative 5 over 2 plus 2. And what was the answer we found on Friday? What was this part? Nobody takes notes? What was it?
16 and 3/4.
15?
16 and 3/4.
That's right. Thank you. Let's compute this 25 over 4, set the common denominators and divide, you get 1675. That was fast, right? Of course, if you have a calculator and do this. Alright, but they still want the vertex form. No, they don't. They don't want it. No, they don't want it. But I'm still curious. In part Z, I want to ask you vertex form, part Z. I'm wondering the vertex form of this thing. Can you give it to me without doing the complete into square? It's, I know, 3 times something x with a number and another number. You need to find out 2 numbers. Guess where they are? You already found them. What is the first number? 2.5, negative 2.5, or 5 over 2. Let's change this into decimal. This is negative 2.5, and this is 1675. Am I right? No, I made a mistake. Yeah. We always take opposite of this number, so it's plus. What's that? No. This one is always the same, the second one. We only flip the first one, okay? We only change the first one. But isn't this how what we have done here? We had minus 3, I made it positive 3. We had minus 4, I didn't touch it, it's minus 4. Okay? Alright, do you like this formula better? No? How many of you guys like the formula better? Raise hand. How about the previous method? You like it better? And you're weird. You usually like formulas better, but because the numbers were ugly here, 2.5, 16, 75, maybe. But in any case, you have an option to get vertex form and vertex coordinate quickly, not quickly, alternatively by a formula. Okay, in the remaining parts, you just need to read this data from this form or this vertex coordinates. Okay, I will ask them verbally and you will tell me. What is the axis of symmetry for this function? X equals negative 2.5. What's that?
16.75.
What is this?
Is that axis of symmetry because it's the y?
No, axis of symmetry is the x coordinate. This is axis of symmetry. But the second one is also something. It's not the axis of symmetry. Second one is
Minimum.
minimum or maximum depending on the shape. Which one do we have? Look at the shape. Is this a U shape? Upside down U shape. It's U, rising upward. If you have a rising upward thing, this is minimum. If this is the minimum, range is, domain is everywhere, but range is 1675 and all the way to infinity, right? You can sketch the graph because you know the seed location and directions. And you can get y-intercept, x-intercept with less effort. You just need to flip things, set y into 0 and leave x alone. Y-intercept, I already know it, it's 2. 0, 0, 2. Okay? So I'm not gonna spend time on this one anymore. Are we good? Alright. We're gonna make an application of this what we learned. Because these quadratic functions show up a lot. Show up in our real life. Those parabolas. I want you to read first. Take a minute to understand, digest the information. Okay, you're building a garden, but you want to protect your garden from animals, so you want to build a fence around it. It's a rectangular shape garden, but one side already you have a fence. It's already been built in by the neighbors. Neighbor's property has a fence. So all you need to do is cover the 3 remaining sides. Alright. You can't build any garden of your choice. I mean, you don't choose this freely because you don't have enough money to go with your dream garden size. You have only 200 feet long fencing. Your money is enough to cover perimeter of this shape, 3 sides perimeter, and only you have 200 feet long fencing available to you. How would you spend this 200 feet long wire or whatever fencing you're using to get the largest garden? Because you want to build the largest so you can get the most vegetable out of it, right? You don't want to make a tiny one. So there are options. I can go with 1 feet on this side, 1 feet on this side, and 198 here. There you go. I spent 200 foot long, right? 198, 99, 200. That's a really tiny length, tiny width, and very long garden. But how much the area right now? What is this area? What is the area of a rectangle? Length times width, right? Which is 1 times 198, 198 foot square. It's even less than my bedroom. Right? You can't grow much. You can't feed your family with this, right? So let's make better choices. Don't just make 1 foot long width. How about 2 foot long? 2 here, 2 there, and how much left here? 196, right? Now, when you multiply 2 and 196, it is 392. Now it's bigger than my bedroom, but still too small. I think you can do better than this. Are we gonna go with trial and error? No. We need to find that exact best maximum area covered here. And math, quadratic functions will do that. Okay? Will tell you what sizes you need to take. So before anything else, figure out the formula for whatever you are maximizing. What are we maximizing here? Where is the word maximum? We are here, and the following word is maximum followed by area. So the formula or function you are trying to maximize is area, and you need to tell me that formula by the variables picked by the author already. It is length times width, which is xy. Okay. Let's peek at the previous question. This function had a minimum, not this one. This one had a minimum as well. This one had a maximum. So you learn how to find maximum of quadratic functions, right? What value is the maximum? This second number. So this gives me an idea. If I build a quadratic function like this and find its vertex form and get y-coordinate of the vertex, there you go. That's the maximum area I should make. Okay? So all you need to do is get a quadratic function of single variable x. I need to see x with a square and stuff. Now how many variables do you see here? How many? 2. I don't know what to do with y. This function has 2 variables. I need to convert this y into x's. I need to get this y as 3x plus 6 maybe, I don't know, but I need to change it. For this, you need to refer to the statement, given data, and find a relation between x and y. Where is it? I need to build an equation between x and y so I can leave y alone, get in terms of x. What information? I haven't used it. All I used is my geometry knowledge. X times y is area. I haven't used this yet. What is 200? It's the total fencing. 3-side total must make 200. Can you build an equation out of it? Can you?
Y plus 2x equals 200.
Right. Left side, right side, and the bottom side together, left, right, and bottom side total perimeter fencing I need must be exactly 200. So this tells me that these two is double x. Y is actually 200 minus 2x. And I can make it right here. I can put this in here. Okay? And can I call this, instead of area, A as in first letter of area, A of x, to be maximized? You're maximizing this. Maximize this function, but what is its equation? X squared minus 200 x. Correct? No, I made a mistake. Minus x squared plus 200x, right? X times minus x is minus x squared. X times 200 is 200x.
Should there be a 2 in front of class X?
Yeah, I missed somewhere, right?
Like 200 minus 2x?
Right. This was 2. Thank you. So it is minus 2 x squared plus 200x. Now, all you need to do is, this is your quadratic function. What is the last term? Usually you expect to see 3 terms, but the third term is missing. Then it says default, just zero it. If you want to use the formula, etc., I mean, you don't need this actually. I don't know why I put it, but usually we deal with 3 terms. If you miss the third term, yeah, there you go, it's 0. Let's make a complete square. I need to get the vertex, okay? So I can measure the maximum and where it happens. So how do I get the vertex form of this? Remember the procedure? We first factor out this number. Minus 2 out. It's x squared plus, when you divide by 2, this is 100. X. You have plus 0. Correct? That's what I meant. I was just checking you this. It's minus 200 because 200 divided by minus is minus 200. Minus 100. I kept some space here because something will be following it. Maybe more space. Because it's going to be a big number, I believe. What number are we going to add in here? We are going to make one number here. So that we can have 3 terms. It's going to turn into a square of something. There is a number here, 1 squared. It's going to make this third number. What is that third number? 2500. How'd you get it?
50 squared.
Yep. We take half and square. Half of this number and square. Half of 100 is 50. Take 50 times 50, 2,500. But I need to take this away again on the end, right? And am I gonna take 2,500 from the end? No. 2 times 2,500. So I will take away 5,000. All right, let's see who's awake. I'm taking 5,000 off so that I can compensate my addition of 2,500. Something is wrong. A friend says this time we should be adding 5,000. Why? We were always subtracting here. In this question we subtracted. And this one, when we were doing on Friday, we subtracted, I believe, on the end. Why is it addition today? Because when I add 2,500 here, the real effect I'm making is minus 2 times that quantity, which is minus 5,000 I'm putting into equation. I put minus 5,000. So I need to do the opposite of what I just did. I need to add here 5,000 this time to compensate what I destroyed in this part. Okay? Make sense? Alright, when I turn this trig term into binomial square, what is the number here coming up? It's this number half. It's 50. And we have now 5,000 on the end, 0 plus 5,000. And this is it. You have your area function for any x dimension you choose. This is the area you're gonna get. Now, let's get the vertex. Vertex is since this is upside down, downward, this is downward. Wherever vertex is, you're gonna go down. So vertex coordinates are 50, 5,000. Where's 50? Let's say 50 here. 5,000 is 10 times this distance here. This is your graph. This is the maximum. Okay? Makes sense? Now, they ask me what is the maximum garden size with 200 feet long fencing. This is the area, maximum area you can build with 200 feet long fence is 5,000. Oh my God, my initial build was 198 square feet. Now it's 5,000, it's a mansion. It's a huge garden, right? It makes a huge difference. But what are the sizes I need to build? The result I got is, this is 5,000, but I'm wondering what is width and length I need to come up with. You actually found x value too. You're not aware of it. You found it. What is the x value that creates 5,000 square feet area? It's 50, it's right here. X's are here, still that same x from the sides. So this x is your width. Width size 50 gives you 5,000. So not only area, but width x is 50 as well. Well, if width is 50, how do I get the length? In case they ask. How do I get y? Have we built the equation between x and y somewhere? Are we? If this is 50, what is y? Or in other words, you spent 50 here, 50 there. How much left for y? 100. Okay? Let's see what is asked. I don't know if all information we found needed. Yeah, they want width and length. I don't know which one width, which one length, so you can put in arbitrary order. 50 by 100, it's fine, and the maximum area is 5,000. Okay? Any questions? All you need to do, main part is get the function of single variable. Start with the area what you're maximizing, and then reduce it to single variable by using the extra information given. Okay? Once you get the quadratic function, you know how to find maximum of it. Get the vertex formula, maximum value. All right. Only 4 questions, but we spent 2 class hours on this. That means it's important. You learned a lot of new stuff here. And question like this is gonna be worth a lot of points in exam because it's 8 parts and it measures a lot of things you know about math. So please pay attention to this homework and solve not only 4 questions, but practice more if you're slow, okay? Sign in if you haven't done so.
That's why I saw that rap.